personal protective equipment. Today's complex environment offers a multitude of problems for firefighters. Firefighters must understand the problems and respond to these situations with all protections they can afford. The best equipment is worthless if firefighters do not properly wear everything provided. Many injuries can be prevented or the severity reduced with the correct use of full protective equipment. Different types of operations require different types of personal protective equipment. Structural firefighting, or turnout, bunkers. NFPA 1971, the standard on protective ensembles for structural firefighting and proximity firefighting, sets the minimum design, performance, and certification requirements for structural firefighting protective clothing. All components must have an appropriate label permanently attached which states, this structural firefighting protective, whatever the garment may be, meets the requirements of NFPA 1971, standard on protective ensemble for structural firefighting. Firefighters must always be aware of the limitations of each piece of PPE. It is designed to protect the body from external heat. It inhibits the transfer of heat away from the body. Body heat and moisture can get trapped within your turnout clothing. The cooling effects of sweating are limited during work. It increases your heart rate, respiration, and core temperature. And it's important to remove your turnout coat during breaks. Protective clothing should never be altered. It can void the warranty, can affect you receiving workers' compensation benefits, and it endangers personnel. Some limitations. Increases the risk of heat stress. Burns may be suffered with no warning. It decreases your ability to feel heat. Damaged gear creates greater risk. Structural PPE provides no protection from chemical hazards, biological hazards, nuclear hazards, explosive hazards. Your helmet. Traditional function of a fire helmet was to prevent hot water and embers from reaching your ears and neck. Newer helmets still provide water protection and impact protection, temperature protection, and face and eye protection. Helmets shall consist of at least all of the following assembled components: the shell, the energy absorbing system, retention system, fluorescent and reflective trim, ear covers, face shield or goggles or both. Ear flaps, neck covers must be worn during firefighting. They're not there for decoration. Face shields do not provide adequate protection from flying particles or splashes. NFPA 1500 requires goggles or other primary eye protection if protection from flying particles or chemicals is required. Eye injuries are some of the most common. Safety glasses and goggles protect against 85% of all eye hazards. Eye protection is necessary when working with tools, working with chemicals, conducting vehicle extrication, possible exposure to bodily fluids, and fighting wildland fires. protective hoods are vital to protect ears, neck, and face from heat and debris. And it covers areas not protected by your SCBA facepiece, helmet, ear flaps, or coat collar. And it must be used whenever an SCBA is worn. No part of the hood should be between the skin and your SCBA facepiece. The hood should be donned before the turnout coat to keep the bottom of the hood under the coat, and the hood must be pulled over the head after donning the SCBA facepiece. Protective coats provides protection in structural firefighting and other emergencies. Must have 3 layers of lightweight materials with air in between. Your outer shell is lightweight and flame resistant. Has a vapor barrier made of either Gore-Tex, neoprene, or vinyl, and an inner lining, which is lightweight and normally non-removable. Turnout coats provide limited protection from direct flame contact, hot water and steam, cold temperatures, and environmental hazards. Some additional features. Collars with a closure must be turned up for neck protection. Wristlets prevent water, embers, and debris from entering your sleeves. And the front closure system prevents water and fire products from entering. Newer coats are equipped with a drag rescue device, or DRD. It's a built-in harness and hand loop at the back of the neck to allow another rescuer to grab and drag a downed firefighter. Protective pants has the same design requirements of layers as required for your turnout coat. It is the only NFPA approved lower extremity covering. Normally reinforced knees and cuffs add durability. And suspenders are necessary so the pants do not sag when they're wet. Firefighting gloves must be resistant to heat and flame. They have penetration resistance, cut resistance, they're resistant to weather and moisture, and they need to properly fit so that they're designed and that you can use them properly, the dexterity, so you can grip tools and hose. NFPA approved firefighting boots provide protection from hot embers and water, nails, glass, other sharp objects, bodily fluids, punctures and cuts, crushing injuries, electricity. Structural firefighting boots may be leather or rubber. Thermal, physical, and moisture protection shall be continuous for the entire footwear height. They have a steel sole plate for puncture protection. They have insulation bonded to the boot shell for thermal protection. Firefighters are constantly exposed to loud noises in the station when responding and on scene. Many departments provide hearing protection procedures for their use. Apparatus intercom systems provide hearing protection and communications. Wearing hearing protection during structural firefighting is impractical and hampers operations by interfering with on-scene communication, cries for help, sounds indicating possible collapse, and evacuation signals. PASS device, Personal Alert Safety System. Designed to alert others when a firefighter has stopped moving and may be in distress. They activate if motionless for approximately 30 seconds. The device sounds loud, pulsating noise with flashing lights. The alert can be operated manually if the firefighter is conscious and in trouble, and it assists rescuers to locate a downed firefighter. Newer SCBA have a built-in or integrated pass device, which is activated when the mainline valve is open. Pass devices must be maintained according to manufacturer's instructions. Firefighters must be trained how to initiate an alert signal and how to react to the alert signal. Retraining should be conducted twice a year. And SCBA and pass devices should be checked daily and before each. Rescuers should be trained to listen for the alert signal when searching by stopping together and controlling breathing. When a downed firefighter is found, the pass device should be silenced to notify others. Wildland protective clothing. Structural firefighting turnout gear is too heavy and bulky for use in wildland firefighting. Wildland gear should meet the requirements of NFPA 1977, Standard on Protective Clothing and Equipment for Wildland Firefighting. Wildland protective clothing includes brush, jacket, or pants, or one-piece jumpsuits, gloves, goggles, head and neck protection, and footwear. Jackets, pants, or coveralls must meet fire-resistant requirements. Helmets with chin straps and should have a protective shroud. Wildland boots must be at least 8 to 10 inches high and provide heat and slip protection. A fire shelter. Fire-resistant aluminized fabric covers that protect a firefighter from convective and radiant heat. A load-carrying or load-bearing equipment, a belt and suspender system to distribute the equipment's weight. Respiratory protection. NFPA approved air purifying respirators and powered air purifying respirators should be available. Chainsaw protection. Chaps, leggings, or pants made of ballistic nylon. Emergency operations along roadways are extremely dangerous. The best protection is to be visible and work behind a barrier formed by the apparatus. Federal law requires firefighters and other emergency responders working within the right-of-way of a federal aid highway to wear a high-visibility safety apparel. Safety vests must meet the Performance Class 2 or 3 requirements of the American National Standards Institute. Minimum requirements include use of fluorescent yellow, green, orange, red, or red background material with 360-degree reflective visibility. Personnel must protect themselves from exposure to infectious bodily fluids and airborne pathogens when giving medical care. Medical protective clothing must be NFPA 1999, Standard on Protective Clothing for Emergency Medical Operations, and include utility gloves, medical exam gloves, eye and face protection, face mask, footwear covers, medical garments, medical helmets, and respiratory protection. Technical or special rescue PPE to protect personnel from physical, thermal, liquid, and infectious disease hazards. Should meet the requirements of NFPA 1951, Standard on Protective Ensembles for Technical Rescue Incidents. Water rescue PPE. Full body wetsuit, buoyant, thermally insulated and abrasion resistant, a rescue helmet, and a Coast Guard approved personal flotation device. Ice rescue PPE. Full body dry suit with more thermal insulation than those used in water rescue. Hazardous materials PPE. Various types, including fully encapsulating suits, which provide splash and vapor protection. Proximity firefighting protection clothing. Similar to structural protective clothing, but with aluminized outer covering to reflect radiant heat. Station and work uniforms should meet the requirements of NFPA 1975, standard on station work uniforms for fire and emergency services. To be approved, no garment component is to ignite, melt, drip, or separate when exposed to 500 degrees Fahrenheit for 5 minutes. Care of your protective clothing. Contamination of protective clothing by hydrocarbons or soot reduces its fire resistance. Chemicals or petroleum products on turnout gear will create a fire hazard. Manufacturer's recommendations should be followed to ensure durability and endurance of the protection provided. PPE should be inspected at the beginning of a shift, after every use, after washing or repairing, and on a routine basis. Due to soiling or contamination, any damaged hardware or closures, physical damage, thermal damage, damaged reflective trim, any shrinkage, cracks, melting, or abrasions in helmets, missing or damaged face shields, or leaking footwear. Your helmet. Clean off the dirt and soot. Any chemicals or petroleum products must be cleaned off as soon as possible. Replace helmets that do not fit properly. Replace cracked, scratched, or heat-damaged face shields, and inspect the suspension system frequently. Follow manufacturer's procedures when repairing a helmet. Coats, pants, and hoods. Coats and pants can be hand scrubbed with a mild soap and water, rinsed and hung to dry. Extraction washers need to be used to launder turnout gear. Turnouts should not be dried or stored in direct sunlight because ultraviolet light degrades the fabric. High-pressure washers will damage the protective fabrics and should not be used. Most gloves can be cleaned in the same way as coats and pants. Wash oil, grease, chemicals, and debris from boots because they deteriorate rubber. Replace worn, cut, or punctured boots. Leather firefighting boots and gloves contaminated with petroleum products cannot be decontaminated to the point where all of the contaminants can be removed. Some special considerations for PPE. Be aware of the limitations of all your PPE. Make sure your turnout gear is dry before wearing at a fire. PPE insulates from heat but can delay awareness of temperature increases. And never wear PPE that does not fit. Turnout coats should overlap pants by at least 2 inches when you bend over to a 90-degree angle. Thermal burns can happen at compression points where clothing layers are pressed together, such as under an SCBA or wing unit. Radiant heat can cause burns through your turnout gear. Firefighters should move to a safe area and remove PPE if signs of heat exhaustion, such as weakness, dizziness, rapid pulse, or headache develop. PPE will not protect firefighters from backdraft, flashover, or other extreme fire conditions. Respiratory protection. The respiratory tract is highly vulnerable to injury from products of combustion. toxic atmospheres created by fire are described as immediately dangerous to life and health. IDLH atmospheres produce immediate, irreversible, debilitating effects of health. Firefighters must never enter a potentially toxic area without wearing the respiratory protection. Respiratory hazards. Oxygen deficiency. Any atmosphere with less than 19.5% oxygen. As a fire burns, the oxygen can be consumed and the toxic gases produced displace oxygen. Oxygen deficient conditions can be encountered in various non-fire situations, such as carbon monoxide or confined space. Effects of reduced oxygen, or hypoxia. 21% oxygen is normal. 17% oxygen starts increased respirations and muscle impairment. 12% oxygen, dizziness, headache, fatigue. 9% results in unconsciousness. And 6% or less can result in death within a few minutes. Respiratory hazards, elevated temperatures. If taken in the lungs, can cause a serious decrease in blood pressure and circulatory system failure. Can cause pulmonary edema or buildup of fluid in your lungs and asphyxiation. Can cause permanent damage. Can cause spasms of the epiglottis and asphyxiation. Particulate contaminants in smoke. Smoke contains oxygen, nitrogen, carbon dioxide, carbon monoxide, carbon particles, and other toxic byproducts. Can also contain irritants and lethal particles, such as formaldehyde, formic acid, or acrylane. Respiratory hazards, toxic gases. The irritants and toxins produced by a fire cannot be determined accurately. The combination of some of these substances can be more toxic than if inhaled separately. The type and amount of toxic gases depends on the nature of the combustion, the rate of the heating, the temperature the gas is produced, and the oxygen concentration. Carbon monoxide is odorless and colorless. It's produced in almost every fire, the result of incomplete combustion. And the darker the smoke, normally the more CO. It is the largest killer, and it has a cumulative effect. High concentrations can remain even after the fire is extinguished. 0.05% in concentration is dangerous. Unconsciousness and death can occur at levels over 1%. It combines with hemoglobin in your blood 210 times more faster than oxygen. Due to frequent exposure, firefighters can develop a tolerance to carbon monoxide and function without any symptoms. Firefighters can suffer the effects of CO without being aware of it. Overcome firefighters should never re-enter smoke-filled areas. Hydrogen chloride irritates the eyes and the respiratory. It's normally from burning plastic. Hydrogen cyanide created by the incomplete combustion of substances such as natural fiber, resin, synthetic polymers, synthetic rubber, can be inhaled, ingested, or absorbed. It is a chemical asphyxiant which targets the heart and brain. Carbon dioxide 10 to 12% can cause death. It initially increases your breathing rate, and it is a product of complete combustion. Nitrogen dioxide, a pulmonary irritant, blocks the body's respiratory process and is normally given off near grain bins. Phosgene gas mixes with water to form acid in your lungs, and it's created by the burning of refrigerants. Respiratory hazards, non-fire toxic atmospheres. Ammonia, sulfur dioxide are used as refrigerants in commercial occupancies and irritate the respiratory tract and eyes. Chlorine gas leaks may be encountered at manufacturing facilities, water treatment plants, and swimming pools. Toxic gases and oxygen deficiencies will be encountered in confined areas. Hazardous materials can be encountered in any incident and can present a multitude of unknown hazards. Airborne pathogens. Disease-causing microorganisms encountered in medical emergencies, vehicle rescues, and search and recovery operations, such as meningitis, influenza, MRSA. MRSA is methicillin-resistant Staphylococcus aureus, pneumonia, tuberculosis, measles, chickenpox, smallpox. Evolution of breathing apparatus. Beginning in the 19th century, air was pumped through the hose to a helmet or helmets that entrapped air. Starting on the left, a Neely smoke excluding mask, C. Gorman mask, a Baden-Bader smoke protector, and a Merriman smoke mask. Some of the evolution of breathing apparatus after World War I. A Hopkellite gas mask, a type N, did not filter CO. They were cheap and light, but they were deadly in oxygen-deficient atmospheres. Uncertain life of canister, and recalled in 1972. A Draeger, first closed-circuit unit, scrubbed exhaled CO2 to use again, and supplied oxygen at a fixed rate. More evolution of breathing apparatus. After World War I, the Chemox, moisture from exhaled air, reacted with potassium superoxide to liberate oxygen. Canisters were expensive and needed replacement after each use. A Gibbs apparatus, the first closed-circuit apparatus approved by the U.S. Bureau of Mines in the 1920s, and is the forerunner of today's equipment. Evolution of breathing apparatus after World War II. Scott Aviation developed a compressed air demand unit in 1945. You can tell by the pictures it's Scott Aviation for a reason. Scott Aviation, little background here, designed the bottles that you see in the top right hand for use on aircraft, particularly bombers in World War II, and then had a surplus of this equipment and decided to make equipment for firefighting. It's followed later by compressed oxygen and low pressure alarms. Open circuit airline equipment may be needed when personnel must remain in contaminated atmospheres for extended periods. Air hose from a large air supply is connected to an SCBA regulator and a facepiece. Can allow firefighters to travel up to 300 feet from the air supply without the weight of a backpack and cylinder. Primarily used for confined space. Closed circuit SCBA. Exhaled air stays within the system and is reused after carbon dioxide is removed, mixed with additional oxygen. Primary use normally is long duration hazmat incidents. It's typically used in hazmat incidents or shipboard operations of duration up to 4 hours. Uses compressed oxygen, also known as a rebreather apparatus, and it's not approved for firefighting operations. Modern breathing apparatus. Open circuit SCBA. Uses compressed air. Exhaled air is vented to the outside, and it maintains a constant pressure in the facepiece higher than atmospheric pressure to prevent contaminants from entering a facepiece if the seal is broken. Harness and backplate assembly. It's designed to hold the cylinder securely on the back. Has an adjustable harness, straps for a secure fit. Depending on manufacturer, the weight may be distributed on the shoulders or the hips. Common problem is that firefighters may not buckle the waist strap. Air cylinders. Steel, aluminum, or composite. Weight depends on the construction. Fill pressures and air durations. 2,216 psi is rated for a 30-minute. 4,500 psi rated for 30 minutes. 3,000 psi rated for 45 minutes. 4,500 psi rated at 45, and a 4,500 psi that's rated for 60 minutes. Firefighters will get about 1 minute for every 100 psi under working conditions. Hydrostatic testing of cylinders is required by DOT, the Department of Transportation. Steel and aluminum cylinders is every 5 years. A hoop-wrapped cylinder is every 3 years. A fully wrapped fiberglass or Kevlar cylinder is every 3. And fully wrapped carbon fiber cylinders is every 5 years. Cylinder lifespan. Steel and aluminum can be used indefinitely until they fail a hydro test. Hoop wrapped or fully wrapped is 15 years. Cylinders should not be filled if they have exceeded their service life or retest date. The regulator assembly reduces pressure from the air cylinder to just above atmospheric pressure, supplies air when the individual inhales, and pressurizes the facepiece to prevent entry of contaminants. Your mainline valve must be fully open for normal operations. Newer SCBA have only a bypass valve. The system is activated by purging facepiece and then inhaling, or first breath on. Your bypass valve supplies air directly from the cylinder in the event of a regulator failure. An older SCBA with a waist-mounted regulator and a low-pressure hose, or more commonly known as a belt mount regulator, a remote pressure gauge mounted in a position visible to the wearer shows the cylinder pressure, should read within 100 psi of the cylinder gauge. If there's more than 100 psi difference between the cylinder gauge and the remote gauge, rely on the lower reading for the amount. End of service time indicator, also referred to as your low pressure alarm. It's designed to alert the wearer when 20 to 25% of the air pressure is remaining in the cylinder. must be designed to stimulate more than one human sense. Every SCBA manufactured after March 2003 must be equipped with a Rapid Intervention Crew Universal Air Connection, RIC, UAC, or RIT connection. It allows for a cylinder low on air to be transfilled from another cylinder. When connected, the pressure between the cylinders equalizes. Your face piece. The lens is a clear safety plastic mounted in a flexible rubber face piece with a head harness with straps to hold it on your face, a speaking diaphragm, the exhalation out, a heads-up display required on SCBA manufactured after March 2003, and it displays a visual alert, signals for cylinder content and for battery condition. Displays a visual alert signal when the breathing air in the SCBA has reduced to 50% of rated service. Communication systems to connect a two-way radio to the face piece. Eyeglass mounting kits are available because standard glasses will break the seal. Some have voice amplifiers to make communications more understandable. Departments should use a storage method to make donning easier, whether it be a seat mount in a compartment or in a carrying case. Air purifying respirators, or APRs, remove contaminants by passing air through a filter, canister, or cartridge. It can be a full face piece or a half face piece. Particulate filters are single use to protect from large airborne particles, and they have 3 levels of filtration. They cannot be used in an oxygen-deficient atmosphere and are only for hazards which the APR is certified, such as EMS, body recovery, investigations, inspections, agricultural or industrial incidents, around particulate-producing tools, or around animal excrement. The area should be exited and the filter or canister replaced if the end of service time visual indicators shows that the filter is full, the wearer smells or tastes possible contaminants, or breathing becomes labored. Firefighters must be in good physical condition to work in an SCBA and maximize the air supply. Good physical agility is necessary to overcome restrictions. And the shape of the face will also affect the wearer's ability to get a good seal with the face piece. NFPA 1500 7.13, using respiratory protection. Respirators shall not be worn when a member has any conditions that prevent a good face seal. Nothing shall be allowed to enter or pass through the area where the respiratory protection face piece is designed to seal with the face, regardless of the specific fitting test measurement that can be obtained. NFPA 1500 7.13, using respiratory protections. Members who have a beard or facial hair at any point where the face piece is designed to seal with the face, or whose hair could interfere with the operation of the unit, shall not be permitted to use respiratory protection at emergency incidents or in hazardous or potentially hazardous atmospheres. Individuals with facial hair that comes into contact with the SCBA face piece will not be allowed to participate in any live burn skill requiring SCBA and will not be permitted to test for Missouri Firefighter 1 and 2 certification. Eyeglasses with any strap or temple bars that pass through the facepiece to face seal are prohibited. Use of contact lenses is permitted, provided that the member has demonstrated successful long-term contact lens use. Any head covering that passes between the sealing surface of the facepiece and the member's face is prohibited. Facepiece and head harness with strap shall be worn under the protective hood. Firefighters must have the physical strength and size necessary to wear the equipment and perform the necessary duties. Medical factors for SCBA use. Neurological. Good coordination skills are needed for working in SCBA. Muscular. Physical strength and size are necessary to wear an SCBA properly. Respiratory. Proper respiratory function will help maximize the time in an SCBA. A firefighter must be adequately trained and confident in his or her ability, able to maintain control in high-stress situations to reduce any chance of mistakes, able to control effects of claustrophobia from being confined in the unit and the facepiece. Some SCBA limitations: has an increased weight which limits your mobility, limits your visibility. Facepiece limits vision and can become covered with fog. Limited communications. Facepiece limits sound transmission. SCBA limitations: air supply. The harder a firefighter works, the faster the air supply is exhausted. Firefighters must be aware of the amount of time they can be in a hazardous atmosphere. Excitement and apprehension will increase breathing and use more air. Minor leaks or improper regulator adjustments can result in air loss. The cylinder is not full, work time is reduced. And improperly trained and inexperienced personnel use more air than others. Air management for safety and survival. Every firefighter has the responsibility for managing his or her own air supply. Comply with the accountability system in place, and maintain situational awareness. Effective air management includes: know how much air you have at all times, know the point of no return beyond 50% of the air supply of the team member with the lowest gauge reading. Make a conscious decision to stay or leave when your air supply is down to 50%. SCBA air supply should be checked at the beginning of each shift, every time the SCBA is donned when opening the cylinder valve, while working at 5 to 10 minute intervals, during egress from a hazard zone at 2 to 3 minute intervals, and when refilling or replacing a cylinder. Pre-don check. Straps. The mask in the unit should be loose, should be restored to extended positions after checking. Pressure check. The tank should be full. Ensure the tank gauge and remote pressure gauge read within 100 psi of each other. Make sure the high pressure connection is secure. Ensure the tank is secure in the holder. Operate all valves for proper function, and check the pass device. Many fire departments carry the majority of their SCBA mounted in seat mounts to speed the donning process. Seat mounts may be lever clamp, spring clamp, or flat hook. Must only be done safely without removing the seat belt. Firefighters must not breathe cylinder air while seated on the apparatus, and personnel must never stand to don the SCBA while the vehicle is moving. Firefighters must be careful when exiting apparatus due to the extra weight of the SCBA. Specific steps for donning may vary by department policy. Some departments only allow seat-mounted SCBA or the facepiece to be donned upon arrival after the apparatus is stopped. Although seat-mounted SCBA are common, all firefighters must be proficient at donning SCBA from the ground, a storage case, or an apparatus compartment using one of two methods: the coat method or over the head. The over the head method: SCBA positioned with the valve end at the cylinder away from the body. Open the valve fully. Cylinder and regulator pressure gauges compared. Harness assembly is raised over the head. As the unit slides down the wearer's back, the arms slide into the harness shoulder strap loops. The chest strap is fastened and the waist strap buckled. Waist strap and shoulder straps adjusted. The coat method: the SCBA is positioned with the valve end of the cylinder toward the body. The cylinder valve is fully opened. Cylinder and regulator pressure gauges compared. The SCBA is donned like a coat, one arm at a time, through the shoulder strap loops. The chest strap is fastened and the waist strap buckled. Waist strap and shoulder straps are tightened. Donning the facepiece: the major difference between facepieces is some have a rubber harness with adjustable straps and others have a mesh net with adjusting straps. The facepiece must be tightly sealed to the wearer's face to prevent toxic gases from entering. Donning the facepiece: the chin should be centered in the chin cup of the facepiece and the harness pulled over the head. Facepiece straps should be pulled evenly and simultaneously to the rear. Straps should not be pulled outward or to the side. The lower straps should be tightened first, then temple straps, and finally the top straps. The facepiece must be checked for a proper seal and operation of the exhalation valve. Positive pressure should be checked by gently breaking the facepiece seal. The hood must be worn over the facepiece harness and not come between the seal and the skin. The helmet is then donned and the chin strap secured. Doffing procedures differ with SCBA brands. SCBA must be doffed only outside of a contaminated area where it is no longer required. Turn off and disconnect the regulator from the facepiece or the low pressure hose from the regulator, depending on the model. Remove the facepiece. Remove the backplate assembly while protecting the regulator, and close the cylinder valve. Relieve the pressure from the regulator by slowly opening the bypass valve or the mainline valve. Place the facepiece and unit in the appropriate location. Never drop any parts of an SCBA. Never place the unit into areas possibly contaminated, such as runoff from the scene. If not checked every day, SCBA should be checked at least weekly and before and after each use. Check all components for cleanliness and damage. Check the air cylinder for adequate air pressure. Check the hydrostatic test date. Don the facepiece. Check the seal. Check the exhalation valve. Plug the low pressure hose into the regulator or the regulator into the facepiece and ensure the mainline valve is on. Check all hose connections are tight and free of leaks. Compare pressure readings on the gauges. Check for adequate, comfortable airflow. Operate the bypass. Turn the unit off, and bleed the high pressure hose slowly. Check for operation of the low pressure alarm when bleeding the air line. And return all straps, valves, and components back to a ready state. Annual inspection, maintenance, testing, and repair must be done by factory certified technicians in accordance with the manufacturer's specifications. SCBA must be cleaned and sanitized after each use, and the facepiece should be washed with warm water and a mild detergent. It should be rinsed in clean water. The facepiece should then be rinsed in a disinfectant approved by the manufacturer for the SCBA. It should then be rinsed again in clean, warm water. Should then be dried with a lint-free cloth or be air dried. Special attention must be paid to the exhalation valve to ensure its operation. The backplate, straps, and cylinders should be cleaned with a mild detergent and a soft brush. Solvents must never be used on any part of the SCBA. SCBA cylinders, filling safety. Only trained personnel should operate the fill equipment. Cylinders must be inspected before filling. Hearing and eye protection must be worn. Cylinders must be placed in shielded fill stations. Cylinders must be filled slowly to avoid overheating. Cylinders must be filled to capacity, and they must not be overfilled. SCBA cylinder filling procedures vary depending on the cascade used. The following are to be considered guidelines. Check the hydrostatic test date and maximum DOT pressure. Inspect the cylinder. Place the cylinder in the station. Connect the hose from the cascade and open the cylinder valve. Open valve of the cylinder with the lowest pressure but more than the SCBA cylinder. It allows the pressure to equalize. Close the cascade valve and open valve on the cascade cylinder with the next pressure. Repeat steps 6, 7, and 8 until the SCBA cylinder is full, and then close the cascade cylinder valve. Close the SCBA valve, and to bleed the pressure from the fill line and fill hose, and remove the cylinder from the station. Stationary fill stations may employ a cascade system or directly from a compressor system. Mobile fill stations refill cylinders at emergency scenes, and they normally consist of a cascade or compressor mounted on a trailer or apparatus. Firefighter breathing air replenishment systems may be found in some high-rise buildings to provide breathing air to any floor in a structure from a ground level connection. Fire department air connection panel, where connection fittings, control valves, and gauges will be located on the building's exterior. An emergency air storage system will be in place to provide air if a mobile system is not available. Refill panels containing a rupture-proof containment system, control valves, and gauges will be located in protected stairwells or designated floors. One-person cylinder changes. Place the SCBA on a firm surface. Locate a full cylinder. Close the valve. Bleed off the pressure. And disconnect the high pressure. Release the cylinder securing device and replace the empty cylinder with a full cylinder and secure the full cylinder in the harness. Always check the O-ring and the high pressure hose connection. And then repeat and reverse the process. Reconnect high pressure hose, open the cylinder, check the gauges. Two-person cylinder change. Have the firefighter either bend over or get on hands and knees. Find your full cylinder. Close the valve. Bleed the pressure. Disconnect the hose. Release the cylinder securing device. And replace the empty cylinder with a full cylinder. Always check the O-ring. Reconnect the hoses. Open the cylinder and check the gauges. Firefighters must know their limitations and capabilities when using SCBA. The added weight of an SCBA and protective clothing can contribute to firefighter fatigue. Personnel should be trained to recognize the signs of fatigue and heat-related illnesses and closely monitor how they are feeling. Air supply duration varies with cylinder size and pressure, firefighter conditioning, the job being performed, their training level, the operational environment, and the degree of stress. Firefighters must never remove SCBA after entering a contaminated area. An improved visibility does not mean an area is free of contaminants. Atmospheres must be tested with approved instruments that determine the hazards present. Indicators requiring an emergency exit, an activation of the low pressure alarm, an SCBA failure, emergency evac orders, changes in temperature, or signs of collapse or flashover potential. Emergency breathing procedures should be used only as a last resort in life-threatening situations. When air is low, practice skip breathing. Inhale normally, hold your breath as long as it would normally take to exhale, and then inhale again before exhaling. In the event of an SCBA failure, panic causes rapid breathing. Make a conscious effort to control your breathing, and stop and attempt to control your breathing. Alert other team members of the situation. Quickly withdraw to a clear atmosphere. Use any available exit, opening, or create one. In the event of failure of a mainline valve, close the mainline if it's equipped. Slightly open your bypass valve. Bypass must be opened so that adequate breathing air is obtained without breaking the facepiece seal, and allow a small amount of air to flow into the facepiece. Then close the valve. Hold breath until more air is needed. Always keep your hand on the bypass valve and turn the bypass valve on and off as needed. And try to conserve air to one breath every 6 to 8 feet. Regulator breathing after mask or low pressure tube failure. Remove the facepiece and regulator. Shut off the main valve. Bring the regulator up to your mouth, placing the thumb and index finger around the regulator to form a tight seal, and use the bypass valve to give short bursts of air. If separated, lost, or disoriented, use a portable radio to declare a mayday. Activate your pass device, and stop and think, how'd you get where you are? Upstairs, downstairs, right turns, left turns. maybe the last window you passed, and hold your breath and listen. Remember how to find the ways out. Follow a hose line out if possible. Nail coupling indicates the direction to the exit. Crawl in a straight line. Crawl in one direction. All left or right turns in contact with the wall. Call out. Make noise. Break a window or breach a wall. Lie flat on the floor close to a wall if exhausted or losing consciousness. And control the door or close it if not an escape route. Place a flashlight on the floor with the light shining toward the ceiling. Many situations requiring SCBA will have poor visibility due to smoke. Crawling is still the primary method used in areas of obscured visibility. It allows firefighters to avoid heat accumulating at higher levels. It allows firefighters to feel in front as they move. We always work in teams of at least 2 and have a guideline back to the entrance. Follow the walls by placing the right hand on the right wall as entering the area and avoid losing contact with the wall. By following the same wall on the same side, firefighters will move through the entire area and eventually be led back to the entrance. To retreat or leave the area, turn around and place the left hand on the same wall. In an emergency, firefighters may have to exit through an opening that is too small to fit while wearing an SCBA, and it may be necessary to slip out of the SCBA harness assembly, leaving the face piece in place. Remove only the SCBA parts needed to fit through the opening. Complete tank dump for small openings. Loosen and unbuckle straps. Roll the unit onto the left side, removing right arm first. Place the unit on bottle. Gather straps. And push the SCBA through the opening in front using caution not to dislodge the face piece. Firefighters' lives and safety depend more upon their personal protective equipment than any other equipment they use. They must be provided with the best PPE available, and more importantly, use all of the equipment properly. Personnel must understand the limitations of their PPE, not expect it to protect them from all hazards. PPE must be properly maintained, or its protective capabilities will be diminished and endanger the firefighters. A firefighter must be adequately trained and confident in his or her abilities using SCBA and be able to maintain control in high-stress situations.